Hello, welcome to Mechatronics 241 for the fall 2021 term. My name is Andrew Morton and I am your instructor. We're looking here at the Learn site and I'm going to go to Content and then to the Course Info folder, and we're going to look at the course syllabus. Okay, so the name of this course is the Introduction to Computer Structures and Real-Time Systems. It's a bit of a grab bag of a course. It contains a number of different subjects. So just first of all, personnel. You can see my email address there, my office, telephone number. Irene Huang is the lab instructor. She did this course many moons ago when it had a different lab, and now she's back in the course. She's a great lab instructor. I'm happy to have her on the course. And Sina and Reza, both PhD students in ECE, and I've been working with them on this course for a few years now. So the calendar description says it's an introduction to computer organization, so that's carrying on from Mechatronics 262. Basic real-time concepts, process management, interprocess communication and synchronization, memory management, resource management, interrupt handling, concurrent programming, file systems. So that's roughly what we're going to cover. Prerequisites are an intro programming course and a data structures course. And that's really about all that you need. The anti-requisite is a little outdated. ECE 254 went away about a year or two ago, but it was their operating systems course. Okay, the textbook. Douglas Harder taught this course before I did, and he's a lecturer in electrical and computer engineering like me. And he wrote this 600-page textbook after doing the course once, and he hasn't taught it since. But good for him. It's actually a good book, and I've tried others, but I prefer his. And it's free. It's available online, and you can also get print copies at the bookstore. I think that they're between $50 and $60. The logistics for the delivery for this term are that the lectures are all pre-recorded. There are problem sets, and the tutorials for those are also pre-recorded and posted, as are the lab instructions. What we'll be doing in person is every week during the tutorial time, I'm going to be there and I'm going to do a review. So you'll be expected to have done a week's worth of the online lectures and make your notes, and you can come with questions and I'll review important concepts and do some example problems to help with the understanding there. So half you will be there one week, half the other week, and the half that's not in person will be able to watch it live streamed or watch the recording afterwards. We have an online forum for questions, and that is Piazza as usual. There's the link. The evaluation, the labs are worth 28%. I'd actually like to make them worth more, but I looked at the lab average last term and I think it was 98.25, so I can't make it worth too much, or I have to make the tests unreasonably hard. There are 4 tests. They have a weight of 18% each for a total of 72%. I'll give you more details on the labs and the test shortly. Here's the deliverable schedule, and it's roughly the first half of the course on the left, second half on the right. And so the first half is pretty packed. We have something pretty much every week, except for the reading week. But Lab 0 there is really just getting the software installed and choosing a partner for your group. So it's pretty simple. I would recommend you do that in week 1, so September 8th. And then you'll have roughly 2 weeks to work on Lab 1 together, which you'll be demoing on the 22nd. The tests are on the lecture material and problem sets, and they're basically a quarter of the course each. So they're roughly every 3 weeks, as close as I could make it. So the first test is in week 4. The second test is during Mechatronics midterm week. And then if you look at the second half of the term, so starting week 7, there's Lab 3, you skip a week, Lab 4, and then test 3 is in week 10. There's 3 weeks between Lab 4 and Lab 5. Lab 5 is significantly harder than the other labs, and so want to make sure you have enough time. Test 4 will be during the exam period, but it will just be another quarterly test. So, lecture videos are posted on Learn, and there's also a YouTube playlist here. Use whichever is more convenient for you. I guess the advantage of the Learn ones is that you can download them and watch them offline if that's helpful. And then YouTube lets you speed up playback and nice stuff like that. So like I said, I've divided the lecture portion of the course into 4 quarters. And so they have their prescribed lecture videos, which are broken up by topic. And so if we look at the first quarter, for example, the first topic is introduction, and I basically do it page by page. And so there's like 2 videos for page 1 and page 2, I think. And it's just a conceptual introduction to the course. So nothing too hard there. It starts to get more technical after that. The second topic is computer organization. Covers how memory works. So things like SRAM, DRAM, and secondary storage, so like hard drives, SSDs. I added caching and virtual memory because I was hearing that some students encounter this in their job interviews. So we don't go into too much depth just because they're rather large topics, but you at least get a taste for them and have an idea what they're about, microcontroller units. And then there's a section on C programming. So I cover the stuff that you need to know for low-level systems programming I/O devices and stuff like that. So structs, unions, how the preprocessor works, what happens when you're compiling multiple files, and the memory module. Now, each of my videos is kind of Khan Academy style, so I'm writing on the tablet and recording my voice, and I expect you to make your notes as you follow along. Research has shown that you remember things a lot better if you actually write them down than if you just listen to somebody talk about them. So I'm not providing written copies of the notes. You need to go through the videos. And for each quarter, there's 2 problem sets, and they're to give you practice for the test. And so solutions are posted as well as videos that cover those. And I may cover selected questions from the problem sets in the review sessions. I will actually ask for your input on what you want covered in those review sessions. So we have the second quarter covers I/O. So what is memory mapped I/O? How you interface with an I/O device, polling I/O, interrupt-driven I/O, and then we get into the real-time stuff, so scheduling. So I did my PhD in real-time scheduling, and so this is my specialty, I guess, although it's been a while, at least 20 years. But anyway, so we're going to talk about what's a real-time operating system, how does concurrent execution work, timeline scheduling, fixed priority preemptive scheduling, and earliest deadline first scheduling. There's related problem sets. The third quarter covers synchronization. So this is when you have multiple threads or tasks running in parallel or concurrently, I should really say, and how they communicate and synchronize with each other. It's an important skill set. With today's multi-threaded processors, it comes up even if you're doing web programming and you're using things like callback functions. This can be useful to know this kind of stuff. So we're going to cover some synchronization primitives, semaphore, mutex, barrier synchronization. We'll cover some classic problems, priority inversion, deadlock, the dying philosopher's problem, readers, writers. And we'll also cover some memory allocation. So dynamic memory allocation is when you create storage where you request storage for an object while your program's running. So in C++, that would be new. In C, you use malloc and free. Now, for safety-critical real-time systems, you shouldn't use dynamic memory allocation. So we're also going to talk about how to do it statically, which is going to be at compile time or your system startup. And the fourth quarter covers communication. So what's the producer-consumer problem? How does a bounded buffer work? And then we'll talk about queuing theory, which gives you some understanding of how large you need to make your buffers for producers and consumers that are producing and consuming at different rates. And then we'll get into fault tolerance and clock synchronization. This is a bit of, it's got a distributed computing flavor. And finally, I cover a bit of really inter-networking or networking. So it's not covered anywhere else in your curriculum, and it's very important to have if you're going to do systems programming. So I give you the networking light version in about 10 videos, about 3 1-hour lectures worth. The tests will be open book, meaning that you can use your notes, you can use the internet, you may not use cheating websites like Chegg where you can submit a question in real time and ask for an answer. The tests will be timed, so roughly an hour is my plan, and I'll give you a 12-hour window in which to do the test. So I'll consult with your class reps to see what kind of window works well for you, 6 a.m. to 6 p.m., 8:30 to 8:30, or what. I use CrowdMark for submitting the question or the solutions and doing the marking. The late penalty is 5% per minute to, I guess, motivate you to get things submitted on time. And I think it's fair. If you're 20 minutes late, you've lost the whole weight of the test, but it's enough of a deterrent for people not to go over time. Okay, so tests are done individually. You may not discuss it with anyone, whether they're in the class or outside of the class. The labs use the Keil Microvision 5 integrated development environment, and here you're writing C programs. You've learned C++. We're going to tell you a bit about how C works. It's running on SIMSYS RTOS2 operating system. So SIMSYS is ARM's software abstraction layer for their processors, and RTOS2 is their real-time operating system version 2. They're going to be targeted at a certain microcontroller, the LPC 1768, and that microcontroller has an ARM M3 processor plus memory and some peripherals, so timers, serial ports, stuff like that. So the labs, you can see increase in weight from 0.5 for lab 0, which is just to motivate you to find a partner early on, and then 3.5 and 4 and so on. I would say generally they increase in difficulty, and the last lab, as I said before, has the heaviest weight. Labs are done in groups of 2. You have 1 submission per group. Late labs are penalized 20% a day, so you want to get those in on time. Now, I do want to highlight something here, and so each group submits their own independently developed code for each lab. So you're doing your own work for the labs, but I'm also trying to give you a little bit of latitude here, and I borrowed some of this language from ECE 252. So you can discuss design ideas and design alternatives with other groups. You can even help them debug very small fragments of code, a few lines max. Groups are not allowed to share their lab code electronically or in written form, so don't just email another group your code. Unless the group receiving the code, if they're using any of it in their solution, they have to acknowledge it. They have to document it and make it clear to the markers which work is theirs and which work came from someone else, and it will be up to the graders to determine what portion of the mark that was worth. So you don't want to have to resort to doing that. You want to write all of your own code. You could be dinged pretty severely, but if you do have to borrow code, at least if you have acknowledged it properly with the name of the providing group and the date, it won't result in a discipline case going to the associate dean. Now, we will be running Stanford's MOS tool. It's been around for years, measure of software similarity, and it compares programs for how close they are. And it's not fooled by changing variable names or white space or any of those kind of tricks. It's a bit more sophisticated than that. So Microvision 5, the IDE that we're using, it's only designed to run under Windows. So we need a workaround for Mac and Linux users, and so you can use the VirtualBox hypervisor. This is actually what I use. So I'm running Linux on my laptop. I'm running Kubuntu, if you care. So it's Ubuntu with the KDE Plasma 5 windowing system. Anyway, so you can run this hypervisor, and it lets you run Windows as kind of another process. And it's quite good. I find it works just great. Mac users can do the same. If you're a Mac user and your Mac is older, so it's got a slower processor and not a lot of memory, you can also do dual boot, which might be faster. Okay, and regardless if you're doing one of those solutions, you can get a free copy of Windows 10. That's just part of the code supply, or the software supplied by IST for students, and there's instructions there how to get it. You will have access to 27 servers this term that are running the Microvision 5 IDE. You can run your code on one of these servers, and so it's an alternative, I guess, to using the VirtualBox hypervisor, but you'll also be competing with other students for time on the server. So I still recommend, if you're not running Windows, to use VirtualBox. So lab information can be found on Learn, and so you should start by looking at the information on Lab 0. Finally, what should you know about the course? What do I want you to take away from this? And you'll see at the end of each line this square bracket with some kind of gobbledygook in there. And this has to do with the engineering accreditation. They want to know what graduate attributes I'm covering, so knowledge base, and then there's a level there. So I is introductory, D is developing or developed, and A is applied. So I want you to understand the basic structure of a computer system and its components, perform memory mapped I/O, apply real-time scheduling techniques. So you'll be doing that in problem sets, and you'll be doing that on the tests. Program real-time application with multiple coordinated tasks. You'll be doing that in the labs and covering the background for that in the lectures. You will be, I want you to be able to explain task synchronization, including deadlock avoidance. Again, that will be covered in lecture. Want you to have a basic understanding of fault tolerance. Really, it's a fourth year level topic, but there's some useful stuff there for you to know. And want you to have some exposure to basic networking and socket programming, because anybody doing systems programming should know that, no question. And here's the usual university policies, which I'm sure you've seen before. So let's go back to the course site. So let's go to the table of contents, and on the left there you can see we're in the course info section. There's the syllabus I just went over. There's a link to the free textbook and a link to the Faculty of Engineering course responsibilities. Under lectures, I've got my videos posted, and the handouts that are used in some of the lectures, I'll reference them and I'll show you when you need to get them, and some program code that I used if you want to download it and test it on the IDE for whatever reason. You don't need to. Under problem sets, I divide them into quarters, and for each quarter you can see the problem set, the solutions, and there's one tutorial for both problem sets. For the first quarter and the second quarter, there's actually two different tutorial videos. And then lastly, not lastly, there's the tests. I've uploaded the last 2 terms worth of tests. Now note that in the past I've actually made a programming problem part of the tests where you had to compile and submit working code. I'm not doing that this term, just to keep the load down. So you'll see that in these older tests, but you can ignore that part. And I'll be posting test solutions after they've been written to this folder. And then lastly, here's the lab information, and it's still being added to, so I can't show you everything there yet, but it should be there by the time class starts on September 8th. So that's the course. I hope that you enjoy the course, and I'll see you not in the first tutorial on September the 8th, because there won't be anything to review at that point, but the week after that.